Hello everyone, I welcome you all to this lecture, and in this lecture we will be discussing about octahedral voids. So as we know, when solids are arranged in a specific pattern, okay, when atoms are arranged in a specific pattern, then there are some gaps left in between, and these gaps left in between are known as voids. So in the case of crystalline solid, as we know that they are arranged in a specific pattern. So whenever these atoms are arranged in a specific pattern, there are specific kind of voids formed. So there are different kind of voids. Okay, one of them is octahedral void. What is a octahedral void? Octahedral void is formed when six atoms arranged in such a pattern so that three atoms are present in the upper layer and three atoms are present in the lower layer, and the void formed in between is known as octahedral. So this is a 3D diagram. Okay, so octahedral void is something which can be imagined in 3 dimension only, but here with the help of this diagram we will try to imagine the octahedral void. Suppose these two layers are touching each other. So the void present in between here is this is the octahedral void. This is somewhat like this. There are three atoms in the upper layer, lower layer, and there are three atoms present in the lower layer. There are three atoms present in the lower layer. So the void formed in between when three atoms are present in the upper layer and three atoms are present in the lower layer, that void formed is known as octahedral void. That void formed is known as octahedral void. So there are there here we are having the six spheres in case of octahedral void. So we can define octahedral void as void formed by six spheres, void formed by six spheres, where three spheres are present in the upper layer and three spheres are present in the lower layer. And the void formed here is known as octahedral void. This void can be more better imagined with the help of octahedral geometry, okay, which we have studied in chemical bonding, and also we have considered this in the coordination compounds. So octahedral geometry is like this. There are two planes. There is a that is square bipyramidal. We call this geometry as. Okay, so suppose there is a molecule SF6. So four molecules are in the same plane, and one is above the plane, and one is below the plane. Okay. Now this is square bipyramidal. Now see, if I will consider these three atoms, these three atoms like this one, and this one. Okay, they are in the suppose in the same plane, and these three are in the same plane, and they are placed one above another. Okay, they are placed above one another in a opposite manner, such that the void here created is the octahedral void. So this geometry is known as octahedral geometry, and here also this pattern is somewhat similar to this. So these two spheres and these two spheres are in the same plane. Okay, and this one will be the above the plane, and this one will be the below the plane. So it will somewhat look like this. So this is two spheres are in the same plane and two are in the same plane. One is above the plane and one is below the plane. So we can say that in octahedral void there are four spheres basically. Okay, total is six only, and one is above the plane and one is below the plane. And now the void formed in between is the octahedral void. Now we can imagine these as two triangles placed over one another, and the void formed here is the octahedral. So basically, these six spheres are touching each other. Okay, these six spheres are touching each other, where we can consider three spheres are present in the upper layer and three spheres are present in the lower layer. So such is the octahedral void. Okay, so if I would like to draw it in a square using square planar void. Okay, why I'm drawing this? There is a specific reason, because we have to calculate the radius ratio here. Okay, so radius ratio means ratio of radius of atom to the radius of atom of maximum size which could be present in the void. Okay, maximum possible size of the atom that could be present in the void. So their radius is the ratio of their radiuses is the radius ratio. As simple as that. So suppose the radius of atom is r, and the atom which is present in the void, its radius will be smaller. So we have to calculate here the radius ratio r by capital R. Okay, the ratio of uh, radius of atom. Okay, the maximum possible radius of atom which can be present in the void to the radius of the atom, original atom. So that is known as radius ratio. That now we have to calculate for the octahedral void. So while calculating this, let us first, as we know, octahedral void is in the 3D geometry. Okay, this is in the 3D geometry. I have explained that three spheres are in the upper layer, three in the lower layer, and with the help of this pattern. Okay, so I have explained this octahedral void is in many manners. Okay, now let us have a look at uh, 2D void, one of the 2D void, that is square planar void. What is the radius ratio comes in the square planar void? So here are these four atoms touching each other. Now we will consider their centers only. Okay, we will consider their centers only. So here the void is square planar void. I am considering here the square planar void. Let me write this first. Square planar void, and this is something which is present in 2D. Okay, and if I will name this triangle as ABC, and A, B, and C. So here AB is equal to BC, that is equal to A, and that is equal to 2R. Okay, so this is clear. This is R, this is R, and this all is A. A is equal to 2R, AB is equal to BC, and what will be the AC? AC will definitely will be equal to root 2A, and this distance root 2A will be equal to 2 into R plus R, isn't it? So this is the condition. Suppose this is the atom present in the octahedral void, and this is the atom, okay, present on two different sides. Okay, now this is 2R, and this is R, and this is R, and this is the diagonal of the square, which is root 2A according to Pythagoras theorem. Okay, so that's it. Now, just what we have to do is we have to just combine the equations, and the result we will get here is root 2a is equal to 2 into r plus r. On solving, we will get r by r is equal to a is equal to 2r. If I will divide this and solve this, that is equal to root 2 minus 1, I will get here. Okay, and that is equal to 0.414. Whatever the radius ratio, because whatever the atom will be placed in the octahedral void, this its radius will be similar to that of the square planar void. Now this is the thing which is needed to be understood, that whatever the atom, either you are placing one atom above it, either you are placing one atom below it, that is not going to affect the radius ratio. Okay, so the radius ratio of octahedral void is also 0.414. So that was a simple concept of the radius ratio, how to calculate the radius ratio in case of octahedral voids. Thanks for watching the video. Have a great day. Bye bye.